So I told you for G to make the C a plus. Oops, that's a really large marker. So for G, I could take a C out. And then if I take a C out of C cubed, I get C squared. Plus C squared, take a C out, I get C. Plus C, take a C out, what am I left with? A really large 1, right? It doesn't go away, because remember, if I start with 3 terms and I take a GCF out, I better still have 3 terms in that bracket. So I'm going to end up with a plus 1. 3 terms still have to have 3 terms, right? You can't just make one evaporate. So for H, what can I take out? 6. If I take a 6 out of 6n squared, I'm left with n squared minus 30n divided by 6, I'm left with 5n plus 42 divided by 6, I'm left with 7. And then I told you to be confident to box it, even though I didn't do it. And we need equal signs because they're equal. For I, what's the only thing I could take out? Negative. And when you take out a negative 1, it just changes all the signs, right? That's all a negative sign does, is it changes all the signs of everything. So negative 7m squared is going to become positive 7m squared. Negative 10m is going to become positive 10m. And positive 17 is going to become negative 17.
Do we have to do that?
Yeah.
Oh, I didn't. Well, I don't know.
For J, what could I take out? 9 and P. So you could not put them in their own separate brackets, but remember I told you for rationals it's helpful if you put them in their own separate brackets and just to trust me at this point. So 8p cubed divided by 9p is going to be 2p squared, because you're taking 1 out, minus 63 divided by 9 is 7. P squared, take out a p, I'm left with a p, minus 9p divided by 9p is a really big 1. I had 3 terms, I still have 3 terms in here, so that's good. If I don't, I made new. K, what could I do with K? Take out a 2. Can I take out any letters, any variables? No. So I could take out a 2, and then I'm left with 9x squared minus 25y squared, and I'm setting you up for the next lesson, just so you know. 9x squared minus 25y squared is actually a difference of squares. Now, a difference of squares has to have a different sign, so a subtraction sign, and squares. Both of them have to be perfect squares. So if I take the square root of them, they aren't decimals. So let's check it out. So this one has a minus sign, so it's a difference. So that's the first thing. If it's a plus sign, we're done. We can't do anything. Remember that? Plus sign, you're done. So it has a minus sign, and then I take the square root of 9 is 3. The square root of x squared is x. If this was a 9x, I couldn't do it because the x isn't perfect square, right? So not only does the number have to be a perfect square, but the variable does too. Then this one, square root of 25y squared, square root of 25 is 5. Square root of y squared is y. So both of them work out perfectly. There's no decimals. We agree? So this first number, this 2, we write out in front. And then if it's a difference of squares, we go right to 2 brackets, which is going to be the whole next page. The 3x, because it came first, goes in the front of each bracket. The 5y, because it comes last, comes in the second bracket. And then we have to have what? Does anyone remember? 1 plus 1 minus. Because that gets rid of the middle term. If you do plus, plus, and minus, minus, you'll get a middle term. So I expected not everyone to get to this point, but this is how we're going to have to get to in rationals. And L, what could I take out? Anyone know? 25. And Z to the, how many? What's the smallest one? Tyson? 5. So we're going to get 25 Z5. Now we could just write this like this. This is how you write it, and it's completely fine. But I told you that for rationals, it's much more helpful if you actually bracket them because they're both being multiplied, so you don't get confused that they're attached, because they're not. They're only attachments of plus or minus sign. So I write them in separate brackets to set us up for rationals. Then 100 divided by 25 is 4. Z to the 9 minus, take 5 off, is 4. Plus 50 divided by 25 is 2. Take out a 5 of Z to the 6 and left with a Z. I could go Z to the 1. It would be perfectly fine. It just, you won't see a 1 when it's on a multiple choice. And then minus sign. 75 divided by 25 is 3. Z5, take away Z5 is a really large 1. Do I need to write it? No, because it would be 3 times 1, which is 3. I only have to write the 1 if everything goes 3. And then that's it. And we're going to flip over. Oh, of course, I don't have it. So, factoring by difference of squares. So step 1, decide if the 4 terms have anything in common. So I always told you that, I've told you since the beginning, I always told you, I saw you once. I've always told you to take the GCF out first. Okay, no matter what, no matter which one we're looking at, GCF is the very first thing we do. So we take out a GCF, and then every difference of squares problem can be factored as follows. So we have a squared minus b squared will become a plus b, and a minus b, or vice versa, it doesn't matter. And then determine if there's any remaining factors that can be factored further. So we're going to look at b squared minus 64. In order for it to be a difference of squares, first off, it's going to have 2 terms. If it has 3, it can't be, and a different sign, right? So if there's 3 terms or there's a plus sign, it's out. We don't even have to look for difference of squares because you can't. It's a different sign and 2 terms. But the first thing we're always going to look for is GCF. So can I take anything out of b squared minus 64? No. Then next I say, hey, it has a minus sign. I'm going to check for a difference of squares. So how do I check? Difference sign, yes. 2 terms, check. Now I have to see, are they perfect squares? Why is it weird? Square root of b squared is b, so that's good. Square root of 64 is 8. So I'm going to get equal sign because this equals, go to 2 brackets, and it has to be in the order they're given. So b has to come first, and then plus 8 minus 8. What about b? Can I take out a GCF? First question. No. Could it be a difference of squares? Does it have 2 terms? Yes. Different sign? Yes. So now I check. They're perfect squares. Square root of a squared is a. Square root of 144 is 12. So I go equal sign. A plus 12, a minus 12. You guys are going to, oh, and then I box it because I'm confident. You guys are going to try C, D, E, F, G, H. Try them out. The ones on this board. I'm going to walk around and see how you do it. And I'm going to pause it. The first one here, can't you go to GCF? Very first thing I should ask myself. Can I? No. Is it a difference of squares? It has to have 2 terms and a minus sign. So that fulfills. And then I take the square root of 9a squared, I get 3a. I take the square root of 121 and I get 11. The number that actually is most often not realized that it's a perfect square is the number 1. That's the difference of squares that gets missed a lot. So I'm just going to draw your attention to G, for example. This 1 at the back, people won't spot it's a difference of squares. And you're like, obviously I will, because we're doing it right now. But when we do rationals and it's embedded in the rational, these are the ones that get missed the most, the ones where one of the terms is the number 1. You just forget that square root 1 is 1. Okay, so we get 3a in the front of each bracket, and 11 at the back, and plus minus. D, x squared minus 81. Square root x squared and you get x. Square root 81 and you get 9. And so we're going to get x plus 9, x minus 9. How are you doing so far? Good? Good? Okay. Square root of 324 and 289, sorry, is there anything I can take out of them, GCF? No. Square root of 324 is? How much is it, sorry? 18, that's what I thought. And 289, is that 17? Oh, 18a. So I'm going to get 18a plus 17, 18a minus 17. And remember, if you put the minus sign first and the plus sign second, you're totally fine. Don't go changing it to match mine, right? One just needs to be a positive, and one just needs to be a negative. 81 minus m squared. So it's a difference of squares. I can take the square root of 81 and I can get 9. The square root of m squared and I can get m. So I'm going to get 9 minus m, 9 plus m. I'm just going to show you something. So sometimes this is rationals, you guys all did it, doesn't matter if you're coming from dash 2 or dash 1, you did rationals. The catch is sometimes on the bottom, so you'll have a top amount and a bottom amount, and then you want to cancel stuff off. That's rationals. Remember, you have stuff on the top and stuff on the bottom. Sometimes you have like, instead of a 9 minus m, you have an m minus 9 in the bottom. Remember, that's the one where you're going to have to take a negative 1 out and just switches the signs to make it match. So we might have to do that when we get to rationals as well. So 25x squared minus 1. Can't take out a GCF. We're going to check if it's a difference of squares. So we get 5x, and the square root of 1 is 1. So we're going to get 5x plus 1, 5x minus 1. And then h, by then people have forgotten that you should need to check for GCF first to set you up. So what could you take out of this one? Bigger. 4. So we can take a 4 out, and then we're left with x squared minus 9, which is still a difference of squares, right? So we take the square root of x out, we get x. Square root of 9, we get 3. I'm going to show you if you forgot, it doesn't matter. We're going to get 4x minus 3, x plus 3. But what if you forgot? Because the other two are still difference of squares. Not a big deal. Let's go if you did forget. So we have 4x squared minus 36. Square root of 4x is 2x. The square root of 36 is 6. So I could still do this as a difference of squares. I get 2x plus 6, 2x minus 6, which isn't wrong. It's just that I have to keep going. So say that actually happened. Totally fine, right? Don't freak out. I can see, though, that I can take a 2 out of the first bracket, and I can take a 2 out of the last one. So I take a 2 out of this one, GCF, and I get x plus 3. I take a 2 out of the last one, and I get x minus 3. And then my 2 and my 2 can come to the front, so I get 4, x plus 3, x minus 3. Did I end up with the same answer? Totally. But checking for a GCF made it easier if you do the GCF first. If you don't, though, it's not that you can't still do the question, right? You just have a few more steps. And some people get confused with the 2's in front. What should I do with them? So I always say GCF first, just so it's easier. Make sense? Okay, we're going to flip over. Okay, rational expressions. Equivalent rationals and non-permissible values. So rational expressions are when you have something over something. This is my very loose English. So a rational in the past could have been like 4 over 7. A fraction is a rational, right? But then last year we learned, hey, we can actually put variables on top and bottom. So a rational could be like x plus 3 over x minus 7. That also could be a rational expression. And it's an expression because it's not equal to something. Equations equal something. Expressions are just like a fraction or something written out. Non-permissible values, NPVs, or restrictions happen when you have a variable in your denominator. A variable, which is just a letter, in your denominator. What can your denominator not equal? What can the denominator of a fraction not equal? Can't divide by what number? Anyone have any idea? It's round. Yeah. Nope. 0. Yes. So you can't divide by So, if you don't believe me, if you go 7 divided by 0 in your calculator, 7 divided by 0, it will get mad at you. What does it say? Yeah. It just says error. Can't divide by 0, some of them says syntax error. Yeah. 0. Error can't divide by 0. Right? So we're not allowed to do that. So, an example, if I gave you a rational expression of like 1 over x plus 3, I have a variable in my denominator, don't I? Now this variable could stand for any number in the world. We agree? It could be a 7, it could be a 4, it could be an 8, it could be a 10, it could be a 20. There's no restrictions on this x. It could be any number in the world. What number can't it be though? Can't be -3, because what's -3 plus 3? 0, and my only rule is my denominator can't equal 0, right? So what am I going to say when I get these denominators? I'm going to say this, x plus 3, can't equal 0, right? This whole denominator can't equal 0. If the whole denominator equaled 0, it would be dividing by 0, which is illegal, right? So this is an easier one, and Amelia said, hey, what can I add to 3 that would cause it to be 0? Oh, I can add a -3. -3 plus 3 would give me 0, so I know x can't be 3. -3, sorry. If you can't see that right off the hop, just take the whole bottom and say, hey, this can't equal 0, and solve for x. So I'm going to subtract 3 from both sides to get x by itself. So x can't equal -3. So if it's not obvious to you that -3 plus 3 gets me 0, I can solve it every single time and just find out what it is. Okay? And sometimes it gets a bit harder. It's not just like x plus 3 or x minus 3. Sometimes it's like 2x plus 1, which makes it harder. So the reason why we do non-permissible values is our denominator cannot equal 0. So steps to finding a denominator. You have to find NPVs. Factor the denominator. So first thing we're going to want to do is look for greatest common factors, then difference of squares if possible, which is why we went over that previous to this example. This is 30-2 material now. And then set your denominator equal to 0 and solve for the variable. So each of your piece of your denominator that's in brackets, you'll take each of them separately and set it not equal to 0 and solve. So here it says, consider the rational expression x plus 1 over 5x squared minus 5x. Determine the non-permissible values of the rational expression. So right now, if I look here, I'd say, what can I make x be that would make this be 0? And I'm just like, I'm not sure. Some people might say 0. 0 would get it too, but there's also more. So just looking at it like quickly the way it is actually kind of hard. So the first thing we want to do is actually GCF and difference of squares are denominators if we can. So I'm going to rewrite it. I'm going to go x plus 1 over 5x squared minus 5x. My numerator equal 0? Can I go 0 divided by 7 in my calculator? Yep, it'll tell me it's 0. So my numerator can be 0. So when I'm asking for non-permissible values, I actually don't care what's up here. I could have a smiley face up here, or I could draw a pig up here in the numerator, and it wouldn't matter, because my non-permissible values are only based on the denominator. So I don't even spend any time looking at my numerator at all. Could I reduce my numerator? Sure. Is there any point of doing it? Nope, if I'm asking for just non-permissible values. So I just want to reduce this. So I'll leave my x plus 1 sit up here. And because it's attached by a plus sign, I'm going to put it in brackets. Because anything attached by a plus or a minus sign is sewn together. They can't come apart. So when we took a GCF out and we had like a 5 and an x out front, we could put those in separate brackets because they're multiplied. But in this case, if it's just if they're added or subtracted, it's like they're sewn together. So put them in brackets because they're stuck. It's like glue. Okay? So, can I take a GCF out of my denominator? Yes, what could I take out? A 5 and a x. So I take my 5 and my x out. And then I'm left with x. And then 5x divided by 5x is minus 1. And what did I tell you to do with that 5 and that x? I told you to trust me when we were doing it before. Put them in their own brackets because they're multiplied. They're not sewn together with a plus or minus sign. So this 5 is in its own brackets, this x is in its own brackets, and then the x minus 1 is in its own brackets because they're sewn together. We agree? Okay. So I told you that we have to take every single thing in our denominator and say it can't equal 0 and just solve it, correct, for NPVs? So I'm going to take every single thing that's in a bracket, I'm going to set it equal to, not equal to 0 and solve it. So my first one is 5 can't equal 0. That's a true statement. 5 doesn't equal 0. But is there any variables in it? No, so it's not going to cause me any NPVs. So it's just a true statement. Yay, great, thank you. Yes, 5 doesn't equal 0. But no NPVs come from it. Does that make sense? No variables, no NPVs. So now I'm going to take the next bracket. X can't equal 0. It's already done. Box it. Woohoo! X can't equal 0. That's one of them. Happiness. And then our other one is x minus 1. So we're going to do that one. X minus 1 can't equal 0. Am I done this one? No, I have to keep going, right? I need to move that minus 1 to the other side. How do I move a minus 1? Add 1. So x can't equal 1. True. So what are my non-permissible values? My non-permissible values, which I'm going to write as NPVs, but if this is the diploma, I'm going to write non-permissible values. Because I write them as NPVs because I feel like it, but there's no textbook that says non-permissible values can be written as NPVs. That's me short forming it. Okay, and we can't short form our diploma written response. We'd have to write the non-permissible values are blah. But these are our notes. Can we short form in our notes? Yes. Can we short form on a test? No, because we want to practice for our diploma. You could technically short form on a test, and I know what NPV stands for, but we want to practice for our diploma, so we're just not going to short form it all on our tests. We're just going to always practice what we need to do for the end, right? So our notes, we can do what we want. So I'm going to write NPVs because these are my notes. If you want to write non-permissible values because you want to always not short form, go ahead. Your notes, you do what you want. Okay? So the NPVs are x can't equal 0, comma 1. I can put them together. X can't equal 0 and 1, box it. Now I should be able to check these. If I put them back in the denominator, they should result in 0, right? So let's put a 0, let's check them. So I'm going to go 5, this is a check. 5 times 0 squared minus 5 times 0. 5 times 0 is 0 minus 5 times 0 is 0, so I get 0. Yes, so it is an NPV. It would make my denominator be 0, right? Let's check the other one. It's a 1. So 5 times 1 squared minus 5 times 1. When I check, I always check back into the original, not something I've touched. 1 squared is 1, so 5 times 1 is 5, minus 5 times 1 is 5, 5 minus 5 is 0. So I know I have them right. We can check them every single time. You put them back into your original denominator, and if they give you a 0, you did well. Good job. You got it. Now here it says, for B, state the restrictions on the variable. Restrictions is the same thing as non-permissible values. It's what the x can't be. So they, on your diploma, could say, what are the non-permissible values? Or they could say, what are the restrictions? My point of asking these two questions is just to prove that they're the exact same thing. So I'm going to go, x cannot equal 0 and 1. Does that make sense? It's just the same word. So if you want in a different color or in a highlighter, you could highlight it. I would say restrictions equals non-permissible values. They're the same thing, just so you know. Same word. Restrictions, non-permissible values. Same thing. Yeah. Yes. Is it 15? Yes. Boom. Let's go. Good thing we have you. All right. We're going to go down to the, we're going to get our textbooks, then we're going to come back. You will be rejected if you have too many books. So leave your stuff here. We're just going to go to textbooks. So let's go. Asking for principals now. No. Mr. Clay did. I did not. I graduated from Saskatchewan. No, I did not graduate here. Mr. Clay did, though.
Yeah,
He did?
you're gonna have to pay for them?
I don't know. Probably. That's so tough. They just, like, we never use the textbook. It's all online.
But what is one
No, I
online?
hate doing it online. You know?
Yes.
But
No,
no,
they're
the
so
pages
bad.
are so thin. It's gonna rip in a heartbeat. I want to tear it. Like, it is so easy.
Disrespect the book and everything. I hope the rest of it's easy too.
Yeah.
What?
I was surprised to see.
Yeah, bro.
I thought.
You're smart.
Yeah.
I did dash 2 because my brother did it and he said he did dash 2 and then dash 1 and he said it was so much easier because he already was like thinking math. Because like I didn't want to do dash 1 right away because right after summer and not after doing math for a year. I'm not gonna do as well as if I do dash 2 as like a catch up and then dash 1.
True.
I'm just gonna go by this. Right?
For like,
That was only because like
I'm
you
gonna try to
didn't
get
fail
it
this
95.
class, so you're gonna have no math,
Yeah.
and he almost failed foods, so then he wasn't gonna graduate.
I know, in order to fail foods, you have to really
Well,
try.
then he
But he
comes
went
to
back.
school.
That's what I mean, you have to like really try to know.
He's the
But
worst.
that wasn't his fault. His mom was making him go to work for
He's
him, like
like
for
no.
her.
He's
So
like
instead of
he's
her going to
down
work,
the finger. He
he
just like
would go for her, and so he couldn't come to school. It was just really.
You guys can pack your stuff up, because at 25 it's
one more question, then I have to go home.
Are you